This is just an opportunity for folks that couldn't make it to our open house, or for people out of town to understand a little bit about the new research infrastructure that we have, and for you to be able to share that information with different industry partners or other academic partners that may benefit from this. So today we have our Associate Director, Dr. Allison Godwin, here to present a little bit about the workplace simulator components, what kind of things we plan on doing with it. And then as always, we'll have questions at the end if you want to enter them into the chat box. And then with that, I'll let Allison start. Just give me one moment to hand the controls over to her.
Thank you, Brandon. So a few weeks ago, on December 4th, we hosted a very successful open house to highlight and showcase our workplace simulator. As Brandon said, I'm going to give you an overview of what that entails and how you might be able to use it in your workplace or for research and development purposes that you have in mind. So WSIM is what we call this for short, and it does stand for Workplace Simulator. It is housed in the Purdue Central Analytic Facility, and that is part of the very new Cliff Fielding Research, Innovation, and Engineering Building. And this is considered a core piece of infrastructure, or numerous pieces of infrastructure, for the Center for Research in Occupational Safety and Health, or CROSH. And it combines some fairly advanced and unique pieces of equipment to form this world-class laboratory that you're going to be able to do lots of interesting research with. So if you've been on campus recently, this is that new Cliff Fielding Research and Engineering Innovation Building, and it's located, it's not even on the map yet apparently, but it is located in this piece sort of between the Fraser Building and the Parker Building. So it forms a square in the back there. So it is accessible from parking lot number 1, which is associated with the Fraser Building, or our pit parking lot, the P15 at the bottom of the entrance to the university. So that's where you will find it. It's front facing into our courtyard, or you can go in from the Fraser Building or from the back side of the entrance off of parking lot P15. So if you're coming to meet us or to do research or to check out our facilities, that is where the workplace simulator is, and our home base for CROSH still is located over in the Ben Avery building on campus. So we're a little bit spread out, but that's where you'll find us. So we, based on the things that we've put into our workplace simulator, we really do believe that this is a world-class facility, and we are integrating these pieces in ways that have not necessarily been done in any other lab in the world. And it is specifically designed to advance occupational health and safety research conducted by CROSH by combining these key pieces of infrastructure. And with these pieces of infrastructure, we're going to be able to replicate a wide variety of occupational exposures that we see in real-world work situations. However, due to the highly precise technology that we've put into this simulator, us as researchers will have really precise control in order to study a range of responses to any of the conditions that we are interested in. The other unique aspect of this infrastructure is that each piece can be used in isolation or as a unit in and of itself, or we can combine them with all the other pieces or bits and parts of the other pieces, and it'll really depend on the project being done or the research being conducted, which of those we're going to pair together in order to do the investigation. So we see this lab-based research as a way to narrow down some ideal solutions prior to doing field implementation of interventions. So the acquisition of this facility is really helping to drive that middle piece of our field to lab to field research philosophy, meaning now we have a really precise an excellent way to do laboratory work. So we look at things in the field, we gather information about the field conditions, and that might be vibration related or the exposures that a worker is getting. That might be the heat, cold, or humidity that the worker is exposed to. And then we can replicate that in this lab. So it's that middle part of our research development. So if we're able to sort of narrow down what our ideal intervention looks like, then we're going to be able to reduce wait times for meaningful outcomes for industry. We really believe we'll be able to reduce industry costs that were previously associated with lengthy periods of field pilot testing or trying to figure out what's the best solution before you do a full implementation. So the workplace simulator will allow the research team and its industry partners to develop better interventions and to get those interventions to sort of field testing in a more timely fashion. So the pieces that we have, and I'm going to break down what each of them do and sort of the capacity and capabilities of them. So the vibration platform, an environmental chamber, metabolic cart, and a VR eye tracker are the things that I'm going to be discussing today. So there's the vibration platform. This is a motion platform made by the Microlar company, and it moves in 6 degrees of freedom. What that means is that it translates in 3 dimensions, what we would call X, Y, and Z. But those motors on the bottom also allow it to rotate in 3 dimensions, roll, pitch, and yaw. And that capacity allows virtually any movement to be recreated in a lab environment after we've done the measurement in a field situation using our portable accelerometers. So we get the information from the field, and then we use that data to drive this robot inside the workplace simulator. So we typically won't use it just like that. Additional components of mobile equipment or other types of equipment can be secured to the base of that motion platform, that round part on top. So we could put an operator cab on there, vehicle dashboards, control panels, other things to replicate the operational elements that require operator interaction and influence the operating environment, operating comfort and performance for workers. So with this unit, researchers can examine vibration transmissibility, the biodynamic response to that vibration. We can look at vibration-induced injury and at what point that occurs, interventions that might be able to mitigate that injury. We can look at the effects of vibration on performance, in particular fatigue-related effects. And yeah, at all times we can look at the interventions that are going to mitigate the exposure risks to that vibration. So we know that a lot of workplaces have whole body vibration exposures and foot transmitted vibration exposure, and so this unit will definitely allow us to measure that, explore the impact to the human, and then come up with solutions that will try and reduce the impact to the human. We see this unit as being able to facilitate partnerships with manufacturers of equipment, those who may be able to reduce vibration exposure for a worker or improve equipment that will reduce vibration in the workplace. We could look at interventions like seats, cushion materials, suspension systems, anything that would be capable of reducing vibration transmission, we would be able to test in this situation. So for an example use, you can see on the left that we have mounted a seat onto the platform of the vibration platform, and that seat would be secured there. We could tell the motors to replicate what an underground miner would experience in terms of vibration when they are operating any piece of equipment. That might be a load haul dump, that might be a jumbo, that might be a scoop, haul truck, etc. And then we could use other sensors to understand what was being transmitted to the human while they were in that scenario. In the picture on the right, you can see that we have now taken that motion platform and we've put a little bit of a modified cab on there. So this is just a clear plexiglass structure, but it gives the feeling that the user is inside some sort of machine. We can bolt things to that structure in order to better replicate perhaps visibility or other things that might be going on. And we can start to add to that control panels and other things that would start to make it to look like a real piece of equipment. We also have an ongoing study, for example, that's looking at vibration transmission to children who are seated in bike trailers. And so we have, at the moment, bolted a bike trailer to the top of that platform in order to analyze that. So whatever your question is, those motors located on the bottom of the vibration platform can produce the movement that you need to be able to see, and we can do some evaluations. The next piece is the environmental chamber, and here is an external picture of it. It takes up quite a bit of the room inside the room where the workplace simulator is located. So that's an external shot. Some of the pictures that I'm using show equipment inside the environmental chamber, and some of it does not. So that points to the fact that you can use these pieces of equipment in combination or as a single unit. So the environmental chamber allows researchers to replicate the heat, cold, and/or humidity associated with any workplace or condition. And so it's a panelized walk-in temperature and humidity chamber. It's specifically designed to be used with or without that vibration platform or the rotopod that I just talked about. And there are special rails that allow us to move things, to move that vibration platform in and out. It's about 3 meters cubed in size. It's quite tall. The temperature can range between -20 and about 40 degrees Celsius above. And you can range the humidity from about 10 to 95%. So you can tell the computer to hit a very specific temperature and humidity range before doing your testing. It can actually transition temperatures as much as 21 degrees in just 70 minutes. So you can go, the impact of leaving Sudbury in the dead of winter and going to Florida in just 70 minutes. The chamber has a biparting door to allow movement of people or the vibration platform that I just mentioned on this rail system. There's also a 30 centimeter by 30 centimeter porthole that will allow for exchange of materials during a trial, so we can still get things into the unit if we are conducting a long-term trial. And there are some viewing windows as well so that you can see in for observational purposes and just to check on subject comfort. So here are some example uses. On the left, you can see that robotic platform has been moved inside the chamber. So now we could have someone being exposed to a particular vibration profile, and then we could also layer on the impact of heat and or cold into that exposure for the human. So we could in particular replicate sort of the vibration you might experience by a sidewalk plow operator. I've seen these around town a few times already this year. And I was really interested in what the effect of temperature would be because it had a lot less compliance at very cool parts or at very cold temperatures. So what do those, how do those machine parts vibrate when you're looking at -20 versus around 0 degrees? So that sort of gives a good idea of the capacity to look at vibration as well as the impact of temperature. We can also do a variety of exercise-based studies in which the human's response is evaluated when the temperature is either higher or lower than normal. And we would be interested in looking at thermoregulation. So for instance, how much time is required to acclimate to a particular temperature. We could look at the effect of aging or training on temperature regulation during exercise or work. We can look at heat dissipation mechanisms. We can look at cold weather adaptations and or the metabolic response to exercise in either heat or cold. So we have a very fitness-based picture there to show you someone cycling inside the chamber at temperature. We could also do some more work-related tasks inside that chamber, since it is big enough to work around, and we can get a treadmill in there as well. So there's lots of room to be able to replicate the work that might be of interest. The environmental chamber would also be able to measure a product's response to those same heat, cold, humidity conditions. So it's not just humans that we can put in here, but we could look at how electronic products or other units might respond to heat, cold, and humidity. And that might be really important for a company's R&D efforts to figure out whether a particular componentry or equipment is going to be suitable for any particular industry where there's extremes of heat and cold. Now, in that last picture, you saw that the cyclist was hooked up to a face mask, and obviously that has a use as well. And this is what is known as a metabolic cart. So the face mask is going to be analyzing all of the inspired and expired gases that the worker or the athlete or the user is inspiring and expiring during the time that they're in doing the work. And so metabolic carts are used to measure exercise responses. It has the ability to look at ventilation aspects, so how hard and how fast someone might be breathing. It can look at the amount of oxygen being consumed at both submaximal and maximal levels of exercise, and that tells us something about the fitness of a user or a worker, and how that might change over time, or with age, or with other conditions associated with fatigue or work-related factors. This machine can also tell us the type of fuel that's being used to do different rates of exercise or work, and it does so by analyzing, again, that air that is expired by the worker at the time that they're doing the exercise. This thing can also measure resting metabolic rate, and that might be of interest to understand how that's, or what things influence that over time. And it has as well the capacity to measure a whole range of respiration metrics. So things like forced expiratory volume, which is something that might change with age, training, or even contaminant exposure in the workplace. So there's a fairly large suite of respiration metrics that we can also capture with this particular unit. And lastly, the other piece that belongs in this workplace simulator is a virtual reality eye tracker. And so within the center, we have a simulation of an underground operating game, I guess you would say, simulator. So that thing is experienced by users using a virtual reality headset. And this thing is now equipped to be able to monitor where someone is looking at any point in time while they're in an immersed virtual reality environment. And so you can see that on the left now we have the vibration platform outfitted. We've got a seat typical to what you would see underground. We have the fake cab also mounted onto the vibration platform, and we have the user operating what is an LHD in an underground scenario. So what they are looking at in that virtual reality headset is in the picture in the center there. And we can look at a lot of different options in terms of what the cab design might look like, what a proximity detection system might optimally look like. And I think the benefit of using virtual reality to explore some of those options is that you can look at a wide range of options, because you just have to code what you want in there, and then you can test or evaluate the user's response to those changes that you've made to design of the interface or other control features. So the novelty of the eye tracker now being embedded in the virtual reality environment is that we can start to quantify exactly how much time and how much cognitive capacity they've put towards looking at a particular aspect of driving or a particular display that's supposed to be helping them to navigate it underground more safely. And so that gives us some fairly objective numbers to start to evaluate those types of interfaces. And so those are the 4 pieces of the workplace simulator that I wanted to introduce you to today. And thank you for listening. If you have an idea of some sort of research or research and development that you'd like to pursue, please reach out to us, crosh@laurentian.ca, and we can see how we can make this workplace simulator work for your project.